are doing well. Welcome to this video. Today I did a model of the bullet impact onto the polyether ketone. Here is CFRP, the green. Here is CFRP, here is polyether ketone, here is ceramic, and here is gelatin or human tissue here. And let me use the view ODB mirror, use this option to have a full view. And first let me click on animate and let me replace first the CFRP for now. This is the CFRP, and if I click on damage interval for this, you can see the damage and damage for the fiber here. This is the tension damage, matrix damage for the fiber, you can see that, and here the element dilation happened for this, and the tension for the matrix. This is for the CFRP. You can see that after the CFRP, let me request first the estrus, request the polyether ketone. This is the estrus for this. Here is failed at the middle, and the Johnson Cook exactly here, plastic strain or the displacement. Now replace this third layer. It is silicon carbide. See the silicon carbide XY view and here. And if I request the damage for it, click on animate, you can see the damage propagation in the ceramic as a middle layer to waste the kinetic energy of the bullet. This is the bulletproof panel for the gelatin. You can see the damage which happened. It is too much pressure due to buckling, ductile damage, plastic strain, yield criterion, or anything else. You can see that. And now let me request the stress and replace the gelatin. The gelatin, you can see these are the failed elements. We can remove these elements here. These are the failed elements here and here. See that these are the failed element, and you can see here is the damaged area. This is the stress and the plastic strain or anything else. Now let me replace all and check it in this view, and let me remove this element here. And let me click on animate, and this is the impact model. CFRP, polyether ketone, ceramic, and then the gelatin. We use Hashing damage for the CFRP, Johnson Cook for polyether, Johnson Hallam Quist or JH2 for ceramic, and elastic plastic model for the gelatin as the back layer. So if you need to model the high velocity impact for a panel like this, you can come to our website here, www.abacusfm.com. Find the English tutorial here, then click on the title or blue sign. First you will have the definition of the geometries here, material method, interaction load, and then the mesh, and the result as figures. You can see them here. The cost for the CIMP English video is 26 euros and reference paper for the material, and you can use a PayPal account, a Visa or MasterCard for the payment. Before that, send me an email to tell you about the purchasing process. And also we have a full package here. If you need to learn all things in the Abacus, this full package would be a good choice. So it contains anything such as these titles: explosion, impact, welding, biomechanics, forming, cracks, source, CFD, FSI, thermal structural analysis, cyclic loading, discrete, BM method, everything. And the cost for that is so affordable for the student, teacher, or researchers. Each file contains CA, INP, English video file, and paper. And if you want this affordable full package, contact me to this email. Thank you for your attention.